All right, welcome everyone, and good morning. I hope the coffee was good. I missed it. I definitely need some. So we're gonna go over in the next 35 minutes over what a platform as a service is, what you can do with it, what are the benefits, advantages. I just want to know in the audience right now, we're still deploying with FTP. Are there still people doing it? Where do you deploy to? AWS? Other things? Any platform as a service user already? No, really? OK. All right, I hope you'll learn a few things. So just to start, who am I? Guillaume, but everyone's calling me G because my first and last name are just a complete mess. And to tell you how old I am, I started developing on PHP 3. Used Symfony 1 and 1.1 as well. On the side, I'm obsessed by web performance, optimizing all the things. And yeah, in my spare time, just now started building watches, because once again, I'm old and I need to relax. So what we're going to do today, and that's going to be a live demo, so bear with me. Wi-Fi is not that great. Live demo, things happen, so we'll see how it goes. But our goal is going to create... Oh, my boss asked me to stand there, so I'm going to stand there. We're going to deploy two applications, a Symfony application and a React frontend. That's going to be basically just a ChatGPT wrapper. So you ask questions, you get the answers, pretty basic stuff, but including streaming. We're going to deploy that on a platform as a service. And that's where it gets interesting, because you've never heard of Upsun. You've never heard of us before. You've never seen us. You've never seen the brand. We're not really a new kid on the block. We're based out of Platform.sh, which used to be in the Symfony ecosystem for years. And we've just launched, actually today, as of this morning, a new product really targeted at people like you. Thank you, Latoya. It was a tough year. So we launched that this morning. And it's a platform as a service targeted really at developers like you that like to build complex applications with different components, multiple technologies, and stuff like this, obviously based on Symfony as well. So we're going to go over that. We're going to deploy that application. We're going to see performance issues on it, and we're going to try to scale this application afterwards. So let's go over the app quickly. Fairly simple. I'm just going to have a Symfony API, once again, that takes a REST API that takes incoming request, a prompt, basically, send that back to ChatGPT, OpenAI, stream the response back, and then stream that back to the front end, which is fully React static, no next involved or anything like this. If you want the repo, it's available there. Feel free to do whatever you want with it. All right, so let's go. That's where things get actually interesting. I hope the screen is big enough and you will be able to see that. If you're not able, just tell me and I'll try to zoom in as much as I can. So as a lot of different projects, everything starts with a Git repository. Pretty basic. And in that repository, I've got two subfolders. I've got my front-end project, which once again is just a classic React created with React app. And that includes just the bunch of NPM dependencies, all the classics, you know that. And on the back end, we just got the basic Symfony Flex skeleton with just a few controllers. So I'm not going to go over all the code, just go into one, which is the most interesting one, which is basically my message controller. When I send a message to that API, what does it do? It actually stores that in a Postgres database and then send that to OpenAI through their own PHP package. And what's interesting there is that if you just implement the basic OpenAI implementation, you're going to send that text, it's going to be processed, and then you get the result like 2 to 3 seconds later, which is not great for the user experience. So instead of that, what we're going to do is actually create a stream on the OpenAI side, and then as soon as we get one chunk of that response, we're going to stream it back to our front end using Symfony Stream Response. And that's super interesting because that stream response can actually stream anything, files, text, whatever. In that case, we're using event stream. So basically just a bunch of small text, chunk of text, with the data and a few metadata on top. You could also do that in WebSocket and stuff, but WebSockets have a big issue when you're dealing with many messages per second. Sometimes some messages will take more time than the others. That means your content could be all scrambled up. Just a quick note, when you're doing stream response, don't forget to actually flush to make sure that actually the server is actually sending that content right away, not waiting for the whole response to be streamed. All right. So I've got my two applications. I've got 20 minutes left to actually deploy that app to production. Let's test that app first. I'm running that project locally through the Symfony serve command. I've got a Docker container from my Postgres, and I'm running my React. So we're going to create a new chat, and we're going to ask, what do you think of Fabien Potentier? Well, and here we go with the answers. And that everything is running locally on my Mac right now. And yes, Fabien is always the man, the myth, the legend. Thank you, ChatGPT, for that. What's crazy that those answers can be completely random. The one I had previously was not that great, so thanks. All right. The first step, and we're going to need to create a new project on our PaaS, on Upsun. The great thing is that we can do everything through the Symfony command line. Everything is already bundled in the tool you use every day. So we're going to start by creating that project, and obviously my search doesn't work. We're going to create a new ChatGPT 6 project on Upsun through the Symfony CLI. What it's going to do is actually create that project on our side and set up the new remote in our Git project as well. When you create that project, the first step is actually quite important. It's basically where you want to deploy that project. And not all regions and not all data centers are created equal. We've been on a mission for the last 2 years to make sure we can deploy our client's application to the greenest region possible on the different cloud providers. So as you can see in that list, you've got a lot of different providers: AWS, Orange, Azure, GCP. And we also give you an indication of the average carbon footprint of those different regions. And if you don't have any big sovereign requirements, so you need to be hosted in France or Germany, you can actually select a region that is going to consume less fossil fuels and actually generate less carbon. So for the demo this morning, we're going to do EU5 in Sweden, which is great. So we're going to start the creation of that project. Love the ASCII art. And it's going to take a few seconds to actually provision the project on our side. So creating everything. I'm doing everything today through the CLI, because we all love the CLI, but everything is obviously also available on a web console to do all the different action you would want to take or share that with other users in your organization. Everything is meant to be easing the collaboration with your different teams. The goal is that even if it's a tool for developers, by developers, we want to bring all the people from your organization to that. So basically people from marketing, so they can review PR, test branches, whatever that could be. Your project managers to check what is happening, what has been deployed, what is tested right now, how is production, and stuff like this. All right, our project has been created, and Fabien has just released a new update this morning of the CLI. Great. So the next step now is to create that configuration. And for those of you that have used Kubernetes, for example, in the past, you know how the simple YAML thing is not a simple YAML anymore. It's 25 different YAMLs from community plugins, a lot of different stuff, so complex. So what we've tried to do is actually, with just a really simple, smooth learning curve of just a few minutes, you are able to create that YAML. And we also want to automate it. So as you're using Symfony, what we're going to do is actually use the project init feature from Symfony to actually create that configuration. So I'm going to go into my Symfony project right there, and I'm going to init the thing. It's going to detect which version of Symfony you're running. It's going to also detect all the different services you need and create that configuration. If we take a look at that configuration right now, it's fairly simple. You've got a route configuration that is used to actually route traffic based on the domain, the subdomain, or whatever that is, to the correct application. That's going to be important because we have a front end and a back end. And then you've got the description of your app. So basically, my app there is a PHP 8.3. Yes, we support 8.3. I need Composure 2. I need those PHP extensions. Once again, everything has been populated by the Symfony CLI because it knows about your project and has parsed your project configuration. So now I've generated that configuration. But once again, I've got two different projects. I've got my backend and my frontend. So I'm going to move that configuration to, oops, the slash config to slash Upsun to the root level of my repository. So I can now get that config right there. And in that config, I'm going to add my second application. I could deploy first, test my API, and then add my front end. But because I'm time-bound, I need to actually do both at the same time. So excuse me, I'm just going to go up to my notes right there. Come on. And I'm just going to copy-paste this. OK, thank you, the note taker, for the copy-paste feature. Really? OK. And we're going to create a new app. And this is basically all you need to actually add that app to your configuration. You need to add a name, and in that case, it's a React static build. So I'm going to base my container image on Node.js, version 20. And then I'm going to give it also the command to run to actually build and deploy that application. In that case, I'm using bun because it's a new hype thing on JS, and it's supposedly faster, supposedly. And what's going to happen is that we're going to build a project, fetch all the dependencies, create the container image, and push that container to production or to the environment you have deployed your branch. All right. The last step is actually just on the routing, because once again, we have multiple applications. So we need to tell Upsun where to send all the incoming requests for the different subdomains. So I'm creating an API dot and a frontend dot. What you see here is a placeholder, which is especially useful if your project has multiple domains or even hundreds of domains. It's going to pre-populate this with all the different domains in your configuration. So even when you add one domain, it's going to create all the different subdomains and the correct routing on all the different layers. All right. I think I have one last thing to fix. And we're all good. So now, it's pretty easy. We're just going to commit that configuration to the repository. Once again, we like to do what we call deterministic build and deploy, meaning that whenever you deploy something, it should always result in the same thing. And that's really important. And that's why we want to actually do the build on our side, because especially if you have a team of multiple people, those people could use different local versions of their computers, maybe a different PHP version, different database version, or even the JS tooling to build your style sheet or whatever that is. And we want to do that on our side. We need to make sure that whoever on your team pushes some code, it's going to be built and deployed the same way. So now I'm going to use the Symfony deploy command, Symfony deploy command. All right. And it's going to push my branch to the main environment on our site. And as we can see, it's going to start building all our apps. The main benefits of doing this is that tomorrow, if you have a bug on your production environment, you can actually clone that environment in just a few seconds, no matter how much data you have, even if you have a 1 terabyte database. You're able to clone that just in a few seconds and do your testing on a new environment, new isolated environment. So I love this because this morning, the NPM registry was down at 5 a.m., so it blocked everything, but it seems to be working right now. It's going to take a couple of minutes because it's doing a lot of action, all the build, all the packaging, and everything. Obviously, at the same time, if your application is already on production, it's not impacted. Everything is done in the background, and we just replace the different containers whenever we push that at the end, when everything is ready. All right. What we're going to do at the same time also is that we need to configure our project. My REST API is actually talking to OpenAI. So it needs to work with an OpenAI key. So in order to do that, I'm going to create a new environment variable with that OpenAI key to make sure that we can communicate properly. The good thing about this, ooh, what happened? It's always a live demo, isn't it? Right? Let me see. So as you can see, we've got extensive logs where you can actually try to pinpoint what went wrong in that setup. OK, cool. So we're going to create that variable in the meantime. Create variable. And that variable is going to be on our environment, on main, and we're going to name it OpenAI key. Up. Let me get the value for it. If you want free OpenAI credits, use this key. You've got 20 minutes to do it before I remove it. And we're going to see our system is going to redeploy all the different environments with that new key included. The good thing about this is that if you have multiple environments, prod, staging, dev, you can also override those environment variables, so they're actually working at different values on those different environments. So I still need to understand what is happening with that. So obviously, because it's a live demo, I've got a backup, right? So once your project is deployed, we can now test it. And you're going to see that it's a 4.4, but it's expected because it's just the root of my API, so nothing there. But if I actually do a request on a real endpoint, I'm going to get the expected result, JSON result. You can see, I know it's small, but you can see that we've auto-generated all the different host names for this environment. Because right now, my project has no actual domain configured on it. So when we're going to replace that by yourdomain.com, everything's going to be switched automatically. But right now, we're using temporary addresses. And on that project, if I go to the front end now, I've got my React working. I can create a new chat and say, hello, Symfony Con, and it's going to reply with something from ChatGPT. The problem with streams, the way I'm using them, by getting the answer from OpenAI and rebuffering and restreaming that to my front end, is that if the response takes like 3 seconds to generate, I've got a PHP worker working for 3 seconds in the background. So it's not really scalable, because if you have 10,000 of users using your application at the same time, you need to have those 10,000 PHP workers working. Even if they're not consuming a lot of CPU resources, they need to be up and running. So that's not ideal. And we can see that pretty easily. Because we're bundling Blackfire into all our environments, when you deploy a new version, you're going to have all the Blackfire goodness, so all the profiling and all the different monitoring on those different environments. And as you can see on that environment, you've got all the requests, and most of the requests are pretty fast, because once again, I've asked simple questions, so the answer we're getting there really fast. If you want to dig deeper into what's happening in your code, you can see right there that, for example, my main blocker right now is actually my curl response that is doing a stream. And yeah, it's using 85% of my time in my PHP script because it's just waiting for OpenAI to get that data. So one way to correct it would be to actually put that into something asynchronous, like adding Mercure or WebSockets or whatever that could be, and send those messages through events instead of streaming them. But because I'm lazy right now, the way I'm going to do it is by scaling resources. So I'm going to go into my environment. And what's amazing, and for those people that knew us before as Platform.sh, you can now customize your allocation on your different containers. So basically, right now, I've got my Symfony app that is running with one CPU and not a lot of RAM, with 2 instances, my React frontend, same in my database. And basically, you can change all your resources live. And the way you do that is actually, once again, through the Symfony CLI with the resources. So it's not going to work because my project has not been deployed. But you get the exact same thing, and you can set the resources for all your different containers. So I'm going to do that there. I'm going to switch to 4 instances for my backend, just 1 for my frontend. And each of those 4 instances is going to use 1 CPU. And you just click Save, or you do that through the CLI, and it's going to automatically add the nodes in a few seconds. So scaling up or down is really easy. It's just an API call, a CLI command, or a web action. Obviously, you can also trigger that through notification or Blackfire monitoring. Let's say at 4 a.m. in the morning, you have an unexpected spike happening, and Blackfire detects that your response time on your checkout transaction is getting worse. It's going to raise an alert, a notification, and you can actually trigger raising the resources automatically. And when things get better, when they get back on the green, actually bring them down. So it's not yet full auto-scaling. We're getting there. But right now, you can actually prevent your application from going down because of traffic, thanks to those scaling features. And then we can see in our graph right there, we've got all the different CPU resources with the different instances. And once again, a platform as a service is only useful when you know what's happening in the background. That's why we worked for a year on making sure that you've got observability on every level. And when we're talking observability, we're talking performance, logs, and all the kind of metrics that would help you actually pinpoint what is actually happening on your application at any point in time. It's really important for US developers to understand how your application reacts to request traffic and be able to dig deeper into what's happening. Is the database lacking resources? Do I have a SQL request taking too much time blocking my DB? Whatever that could be. That could be a lot of different things. But it's important for you to be able to actually just, in a few seconds, go there and see, oh, yeah, that's where the problem is. If you haven't seen Thomas' talk 1 hour ago, it's all about this. So what we've tried to do with Upsun is really create a new product targeted at the dev audience that should be easy to use, easy to start. We've remade all the onboarding. It's now great. And just in like 10 minutes, you can deploy a fully working test application or even your application if you want to. As we're launching today, we want feedback. And we would love for you to try to spend a few minutes, tell us what you think about it, what actually could be improved, maybe on the technical side, but also more on the product side, maybe on the pricing side, whatever that could be. But we want you're our perfect audience. You're skillful, you know a lot, you've been in that ecosystem for a long time. We need to make sure that product actually fits you super well. So get in touch with us. We can get you on the trial. There are free credits, a lot of different things. We are 20 today on the booth, I think. We want to help you try to do a quick onboarding, explain you what we're doing, and also take all your feedback from what you're doing right now with your current solutions, what could be improved, and stuff like this. Just as a quick note, the big things we're working on right now, obviously everything related to blue-green development, deployment. We know it's not easy, especially in the PHP ecosystem. Blue-green has always been a bit taboo. So we're working on this, improving everything related to scaling. And then, obviously, then on the product itself, everything around permission, authentication, and stuff like this. Despite my little demo issue, I hope that was OK. I hope I was clear enough. Fire up the questions about whatever you want. Oh, and I need to try to hurt someone with this, actually. We want the first question. We can talk about anything. We can talk about Upsun. We can talk about PaaS, deployment. What's the price? So that's one major difference. Thanks for asking. The way we've done that with Platform.sh for years is actually sell plans that were targeted at, for example, you've got a small Drupal, you've got a large Magento. We've decided to base everything usage-based. So now you're paying basically per CPU per second and per memory per second on what you're using. On top of that, we still need to provide some value, so there are user license fees, but they're pretty small, pretty accessible. You can start actually deploying a real production app, I would say like a blog or something like this, around $4 per month. That's really the bottom, really bottom. Obviously, as you scale, if you need database, cache, and stuff like this, classic setup is going to be more around 30 to 40 per month, all included. Anyone else? Oh, cool. I don't have to throw it.
Is there a plan? Is there a plan for automated scaling as well?
Yeah. It's always tricky. Was tricky in automated scaling, and AWS does that amazingly. Because when they scale your resources, they scale your bill as well, right? Without any limit. The problem with automated scaling is that we need to be able to detect when to scale and how much to scale without billing you 10,000 of resources that haven't been used. So it's going to be up to you to actually define your scaling strategy by saying, OK, when my applications scale, the containers that need to scale is usually my database. And I'm adding CPU or memory. And then, for example, I'm punting new horizontal instances on my PHP layer. Once again, the fact that the way we're doing it, all our runtime instances, PHP, Python, Golang, are all stateless. So we can scale them horizontally super easy, right? Usually the problems come with the databases that usually run more vertically, because when you need to actually clone your database to have like multiple read instances, it takes time, it takes resources, and it's usually not better. But yeah, the goal is in the YAML, you will be able to say, OK, I want to scale that first, and here's how much resources you should add every time we need to scale. Oh, that's really far away.
So do you do anything when you deploy a production app? Do you do anything with red, blue environment? So how do you handle downtime? Because if you are pushing to 50 nodes, there must be some differences if I change configuration, for example, or an entity or whatever.
So the way we do it right now is actually we build all those images in the background. We put them on the different hosts that are going to run them. And at the last moment, we switch the network link between the old container and the new one. So the downtime is pretty minimal, but it's there. It's there for a reason. The reason is that if you need to run migrations or any other task when you deploy, we need to wait for that task to complete before actually opening everything. The reason is because you don't want to run an older version or newer version of the code with a different version of the database. So the way we're working is, once again, being flexible enough so that people that are using Symfony that use migration are pretty okay, and we're going to be able to migrate that data somewhere else. Put the production in read-only, migrate the data, and then put everything back in production. But some clients, unfortunately, don't have migration or anything like this. They run custom scripts. And on those ones, we're kind of stuck because everything's going to be every time different based on the project and the client. But the goal for us as a base is to be able to run the migration and then replace everything. Yep.
And then you run the migration, and then you switch everything to the new
Yes.
code base.
Correct.
So minimal but delay, right? So
Yep.
it's at some point you switch.
Yep.
Okay.
Correct.
Thanks.
And the only downside of it is actually if you have a really high traffic website that is doing a lot of changes in the database all the time, that period when we run the migration, we need to pause those transactions and replace them later because we need the migration done before actually rewriting to the database. So that's why we usually have like 5 to 10 seconds where we actually pause the incoming requests, we store them, we roll out the new containers, and then we replay all the requests in the same order. So from a client's perspective, they don't really see it as down. They see it as lagging for a few seconds while their request is being released.
How do you do the last part you said? You say you queue the queries, right? Are you using something, an open source tool for that? Sorry for that inside info, but it's interesting.
Yeah, our router is based on Nginx. I'm not sure if the queuing system is actually another open source library or if that's our own. Nobody from engineering. But yeah, it's Nginx. All right. Thank you, everyone. Have a great day.